So at this time, this is the second part of the framing process. And I want to review some of the material that I brought forth last time, but also to help explain what it is that I've done in my project. Now, let's take a few steps backwards here, just so that you can be reminded on what we actually did. I'm going to go back to the actual design of the different components, take away my structural components. There we go. And there was my deck. So my deck, that's in the brown color, I have two different levels. I have a lower level here and an upper level, and treat them separately, but then eventually combine the two thoughts together. I'll explain what I mean. So for instance, the upper deck, all of the beams are at the same height. So when I look at this beam that runs along this length and along here and here, as well as this beam, are all at the same elevation. So if I stood on the side of the deck, the tops of all these beams would be identical. So that's number one. But then I've got a couple of beams that are going to tie into, or in this case just two that are going to tie into at a lower level. So this beam, which I've got labeled number 3, here, and that one down there, and beam that I've got labeled 2, the two beams to the right, are all at a lower level, and that's to support the joists that sit on top of it. So you'll notice that some of the lower level beams tie into some of the upper level beams. So that's basically the end of one beam sitting on top of the end of another beam that sits on top of a column. You have to try to visualize that. And again, as I mentioned earlier, until you're actually on a construction site and you see it, it's really hard to see, and I understand that. So this particular column must actually be low enough to support the lower beam, and then the upper beam sits on top of it. Or the two of them sit on the same column, and you use what we refer to as squash blocks, which are simply chunks of wood that provide the support underneath the upper beam down to the same level as the lower beam. And like I said, I'll discuss that in greater detail. So when we reviewed this, or when we did this the first time, basically I took the edge, the very most outer edge of my upper deck, and that's shown here in the blue, and I offset that line backwards 2 feet. So remember, the beam runs in the same direction as the pattern of the deck. So the final decking material and the beam run parallel with one another. The floor joists run perpendicular in the opposite direction. That's why when I offset this line 2 feet back, I didn't carry a beam back here because it's in the wrong direction. Anything that's diagonal, like this in through here, I don't actually have any diagonals here. I went straight horizontally or vertically. I did some trim pieces diagonally. It doesn't matter which way the beam runs because they're supported one way or another. So that's how I got this first row of beams. The second row of beams down at the lower level, I took this line and offset it back 2 feet using the same principles. Okay, that's number one. Number two, you'll notice again here, I had to extend the beam because the distance here was too great. These dimensional measurements are very critical. Where we said we want to go 12 to 14 foot as our sort of ideal sweet spot of distance that we're carrying things. 12 to 14 feet. Anything less than that, I've got a few of them that are less than that. You've got way too much beam for what your requirements are. But that's okay. We'll do the calculation regardless. And we make a number of different decisions based on experience, but in this particular case, on what makes scientific sense or structural sense. So I know that from this upper beam to this lower beam, that's way more than my 12 to 14 foot sweet spot, so I had to put a beam in between. Rather than find the midpoint between the two, I just carried this line all the way through. That was a design decision I made. I could have easily said, you know what, I'm going to make a beam through the center. Now the reason I didn't was because now I can share a column. Costs less money to build. Anytime we can share a column, I've got it here, I've got it here, I've got a couple other places, it's much less expensive to build. So it's strictly an economic decision more than anything else. So that's part number one. Part number two is once you've got this layout, and again, it's the type of layout that you're guessing at based on the very first time you're trying it. Once you've got a layout, and I suggest you sketch it. just sketch it right on top. You can scan that image in and email it to me. I'll do a quick review, sketch some stuff up, and bring it back to you. Again, only because this is, it's pretty significant engineering that we're just attempting to. So it's more of you understanding the philosophy behind it and the understanding behind it and some critical points that help you make or help you prevent making mistakes on a site. So that's number one. Number two is to identify what we're referring to here as zones. So what is a zone? A zone is where a structure only has to be calculated once and applies to the entire zone. So for instance, from the building here to the edge of that beam has a pretty definitive dimension. That dimension, I think it's 11 foot and change. I can barely read it here on the corner. Actually, I'm going to come off of this here. And the reason I'm doing this is so that I can zoom out or zoom in. 11 foot 4 1/4. So this zone here has a very specific dimension to it that changes as soon as this beam gets introduced. Now, why did I put the column where I did? Well, this is an angular line, so the actual distance changes all the way along the line. It was just as easy for me to line up columns, because again, now I'm thinking, how is the contractor going to build this? He'd love to have things in alignment, because then he can map out a grid on the site, dig the holes he's done. So I brought the beam down to this level. So you'll notice, if you will, in this area here, from the wall to the beam, it's the same dimension. So since it's all the same dimension, yes, I know it narrows here, this will be zone number 2. And then I will do the calculation for this zone area, the distance from the wall to the beam. So what about here? Well, I've got a consistent distance from the wall to the beam along here. So this is zone number 3. And zones, the concept of zones, may be a bit challenging, but basically you're looking for uniformity. So for instance, look at zone 4. It extends over the greatest area. And I've got diagonal beams running through it and everything else, but realistically speaking, the distance from beam 2 to beam 3 is consistent all the way along this area. That's another reason we lay it out the way we do, so that we have to do fewer calculations. So zone 4 basically runs this entire width. The whole lower level is zone 4. Now you'll notice here, I've called this zone 4. Why? Well, realistically speaking, if I satisfy this condition here, which is the worst case scenario in terms of the distance between beams, which is 9 foot 3 3/4 inch, I will satisfy anything that gets smaller than that. So I don't want a separate calculation for that. I mean, I could. I'm going to save a couple of bucks on some wood. Forget it. What I'm going to do instead is say all of this is the same zone. So all I have to do is one calculation across here, and those joists will be consistent all the way through that part of the project. Now you may say to yourself, well, you got a different beam here. You got a different structure here. Yes and no. I do, to support an opening. But that's the only reason I have it, is to support that opening. In fact, this beam here just does that, supports an opening. It doesn't do anything else. And it carries so little weight that I could have a minimum size beam here allowed by code, and it'll do the job. So remember, the joists hang over this distance, and then it needs separate supports for openings. Okay, let me just zoom back a bit here. And now I'm going to show the concept of framing. So let me go in here. I'm going to turn off the actual visual deck elements, so the pattern of the finished floor, and I'm going to turn on the structure that supports it. Let me just do the first level first, and hopefully this will simplify it. So this is the upper level of the deck. And imagine, if you will, each one of these beams is at the same height all the way through it. And now hopefully you can see the zones a bit clearer. You'll notice this beam, beam number 2, has the same distance all the way through here. Great. Beam number 3 has this very short configuration. Beam number 1 has this very short configuration. Beam number 4 has this short configuration over here. So I've got 4 different size beams based on their spacing, post to post, as well as their distance between that. When I go to calculate the beam, I look at the worst case scenario. Notice this beam here has some really short elements to it. I don't care. I'll ignore that. So what I do is I look at the very longest of element, and that will help me calculate the joist that I need and the beam. So the column-to-column spacing for that beam is 11 foot 8.5. The joist length is the dimension I have here, 9 foot 6.5. The actual, sorry, I should have said the joist span. The joist length is actually 2 feet longer. Remember that. We always overhang by 2 feet because it's a very efficient design. So the joist span is 9 foot 6.5. Now you can see the importance of proper dimensions. Your first row of dimensions should be your distance to columns and any overhang of structure. So that gives me very quick information about where the spans are that I'm going to calculate. When I don't have that, like for instance in here, it was too busy for me to put this 12 foot 8.25 distance, and that's critical because that's the maximum span the joist is going to experience. Now, again, the joist itself is more than 12 foot 8.25, it's 14 foot 8.25. We're not going to get into the really nitty-gritty details of the fact that joists come in 12 foot, 14 foot lengths, and you should design around that. You know what? Any of these cutoffs for this application could be used as blocking. So let's ignore that because I have all sorts of blocking I need cutoffs for. So we really don't consider that an essential element. So there's my zone 3 joist span, 8, 9.5, I think that says. I don't want to lead you wrong, 6.5. The joist span for beam 2, for zone 2 is 12, 8.25. And for zone 1, beam 1, the joist span I have here is 11 foot 4.5 inches. Those are the numbers I'm going to use for my calculations. Why am I not doing it down here? Because if it satisfies what's above it, it will definitely satisfy those elements that are below. Now, zone 4 is actually part of the lower section, so that's why I'm ignoring it in here. Let's take a look at the next level. So I'm going to double click inside my viewport, and I'm going to turn on this time the second deck structure, and I'm going to turn off the first deck structure just so it doesn't interfere, and then we'll have them both on. Oh, it's saying that that's current. Okay, that's fine. So there is my second deck structure, and these are my different zones. So notice I drew the joists coming right up against the beam. Why? The other ones I drew overhang with a 2 foot overhang. These are the joists that are going to overhang the first layer of beams, but tie into the side of the second layer or height of beams. So I've drawn this to show you that these will all require joist hangers that tie into the side of the beam, whereas this is simply overhanging 2 feet over the edge of the beam. That's why we've drawn it the way we have. The actual spacing isn't important because other than 16 inches on center, where you start doesn't matter because whoever the builder is going to start wherever they want. But it's to show that sort of particular element to it. Now I've got some other additional framing because I've got a post of the pergola that sits on top of it, and I want to provide extra joists on either side of it. So here's a beam. You can see it right here. Because it's a beam here and this joist goes right over top of it, I can have 2 short joists going on either side of that post and then another joist on the other side, and they don't have to line up. But that's, at this point, it's not important you understand that as much as you understand how you kind of frame out this entire application or this entire structure. Now you notice here I have joists showing from one side to the other. There's one thing I need to show, and that is right here. It's another ledger that ties off the ends of these joists to sit on top of the beam to provide this opening, this support opening here. So let's take a look at zones. I think this becomes a bit clearer with my separation of layers. Zone 4 is the same distance between beam and beam along this entire length. Notice how beam 2 runs the entire length on one side, beam 3 runs the entire length on the other side. So when I calculate beams, I take the worst case scenario beam. And in this particular case, I've got beam 2, beam 2, beam 2, beam 2. These are all the dimensions down here. And because this beam has less supportive length, then this one here, that's why I'm picking this 12 foot 1 1/8 as my worst case scenario. I satisfy this, I satisfy all the rest. I know that's a lot to take in, but it's conceptualizing how we approach this. Let me just turn back the other layer. Your goal is to be able to zone your entire project out, just the way I have, and you can do that in a sketch design, and submit it to me. Send it to me. It's not for marks. It's for me to quickly review and say, yeah, you could do this, or I will mark it all up and put different columns everywhere and different beams everywhere and say, you know what, yeah, you didn't quite get it, but that's okay. We're going to calculate it based on this and help with your zone requirements. Once you know your zone and the maximum spans of your beams, that's when you can take this whole project and then do what? Do the calculations that we discussed the other day. And I've got on the right side all the different zones and all the different calculations I had done for this particular project. So this file I'm going to make available to you. So if you're completely lost, go back to this. Take a look at it. Figure out what zone or how I calculated the zone, where I got the numbers for the spans, where I got the numbers for the beam center to center, where I got all the information, and then refer back to the charts.